Welcome to today's explainer. We are jumping straight into a core text covering Python list comprehensions and nested structures. But we aren't just going to rehash the basics here. We're actually analyzing these concepts through the lens of a senior developer. So we're talking clean code snippets, common traversal patterns, and the absolute most optimal ways to flatten those complex, deeply nested data structures. Let's get right into it. So you might be wondering, what exactly ties a list comprehension to a nested list? Well, in the world of data processing, pairing these two together is highly deliberate. We're going to investigate how the actual mechanics of a comprehension are uniquely designed to traverse and manipulate multidimensional data super efficiently, basically completely bypassing the overhead of your traditional clunky loops. Truly, it's the defining difference between writing code that just sort of works and writing genuinely Pythonic, highly performant code. All right, let's dive into this. Section 1, Python list comprehensions. At its core, a list comprehension represents a fundamentally optimized approach to processing lists. We are essentially talking about syntactic sugar that taps directly into Python's underlying C implementation. When you use a comprehension, you are explicitly instructing the interpreter to allocate that list in a much more optimized way than if you were just repeatedly calling the append method inside a standard for loop. It's an active, high-performance mechanism for targeted data mutation. Just think about the standard, old-school approach to transforming a list. You define an empty array, you write out a multi-line for loop, and you append items one by one by one. The Pythonic alternative, the comprehension, collapses all of that logic into a single, highly readable line. And this exact phrasing from the text is a great reminder that this isn't just some arbitrary, flashy feature. It's a native design pattern explicitly intended to make your iterables cleaner and your execution times significantly faster. Moving right along, let's look at Section 2, Defining Nested Lists. Shifting over to the structural side of things, a nested list represents your multidimensional arrays, matrices, or those deeply layered JSON-like tree structures. Conceptually, within the Python ecosystem, you're dealing with memory references that are holding on to other memory references. So you aren't just traversing flat data anymore, you're actively navigating depth. And understanding this is absolutely crucial because the memory implications of referencing objects within objects completely changes how you need to approach extracting your data. And honestly, this brings up a classic senior developer pain point. The deeper the structure gets, the significantly harder it becomes to extract flat usable data. When you're dealing with matrices or deeply organized data hierarchies, iterating through them naively is almost guaranteed to result in big O of n-squared complexity, or worse. The actual shape of the data strictly dictates your algorithmic choice here. You literally have to be incredibly careful about how you iterate through these layers, otherwise you're going to hit massive performance bottlenecks. Okay, here is where it all comes together. Section 3, Connecting the Concepts. Now let's intersect that processing approach with the data organization, focusing specifically on how we flatten deep structures. When you're writing a nested list comprehension to flatten a matrix, I know the syntax can feel totally backwards at first. You write item for sublist in nested list for item in sublist. The real trick here is just remembering the left-to-right reading order of those for clauses. It perfectly mimics the exact order you would use if you were writing out standard nested loops, just totally compressed. It really is the most elegant way to collapse multidimensional data down into a single flat array. But from an engineering standpoint, actually applying this takes some serious practical discipline. Step 1. Identify your nested depth. Are you dealing with a simple list of lists, or does this thing go 3 or 4 levels deep? Step 2. Apply the comprehension, but, and this is a big but, never at the expense of readability. A true senior developer knows exactly when not to use a comprehension. I mean, if your one-liner is wrapping across multiple lines and taking the next guy 5 minutes to decipher, you've completely lost the benefit. If you're going past 2 levels deep, using standard explicit loops or maybe importing itertools.chain is almost always the better, more maintainable choice. So to summarize all of this through the lens of clean code, mastering the Python ecosystem requires a really delicate balance between raw power and maintainability. List comprehensions offer you absolutely unmatched speed and brevity when you're processing data, and nested lists provide that flexible architecture you need for complex multidimensional models. But pairing them, that requires discipline. Your goals shouldn't just be to write the absolute shortest code possible, but rather to write the most efficient, legible code that the next engineer on your team can seamlessly understand. As Python continues to evolve, how will balancing elegant one-liners with long-term code readability ultimately shape the future of your data processing pipelines? Because as datasets grow exponentially larger and way more complex, mastering this specific intersection is going to dictate not just your application's speed, but its lifespan and maintainability. Keep that delicate balance in mind as you architect your very next solution. Thanks so much for joining me for today's explainer, and keep coding clean, performant Python.